Welcome to a new test and teardown video. This time it's a INSTEK GOM-802 DC milliohm meter. This one is truly an LED display extravaganza. Oh, look at that many LED displays. Wow. And it's of course because it's able to measure resistance. This is all this thing can do. They do call it a milliohm meter, but in reality this one handles, it got 9 ranges, starting from 30 milliohms, and the last one is 3 mega ohms. So yeah, that will be the resistance range, and of course you'll get test current from 1 amp to 1 microamp. And all those different displays here, they do low and high in percentage. You got the nominal value, so you can compare to that, and then you got the current measured value right here. It's able to do all this high, low, okay, passed test. So if you're doing something in production, it should be super fast and easy to do a production test setup with this unit. Here at the back you can see I don't have the RS-232 or the GPIB interface for connectivity. There is this handler. They just call it handler or scan. That's just a high-low output of all the different test things this unit can test. So that will be pass, fail, too high, too low, ready, and test is done. And you can also put in a temperature sensor so that you can compare your results with a temperature, as far as I understand. That is a little weird because I don't see temperatures in the front. So maybe we should just try and power it up and see what's going on here. I always test with the unit turned off, and then I connect mains voltage, and it is definitely truly 0.0 watts, so that is a good sign. You do turn off everything. Power consumption is only 8 watts, so that is not a lot. Yeah, okay, the supplied Kelvin leads aren't really super impressive. Oh dear, I see a lot of video blinky. That is of course interference with the multiplexing. I will change camera settings. I just took another camera. I think it is a little bit better now, but you can really see the multiplexing. I am now at 30 frames per second, and you can also see my fingers and movement here is not live anymore. It's because I need to use longer shutter times, and still, I mean, if I don't move my head or my eyes, the multiplexing is sort of not visible. But I'm one of these persons that can really see headlight lamps blink on cars and all that kind of stuff. So I mean, if I just move my head or my eyes a little bit, I can really see the multiplexing here is quite intense. So it's definitely not super fast or anything like that. Yes, I was trying to say that the supplied Kelvin leads, they are not the most tip-top kind of quality, but they will maybe do the job. The spring here is not super hard anymore. I mean, you should really have a hard grip on the stuff you're measuring. So that could probably be changed if we change the spring. And they're probably quite alright. But what I don't like is banana contacts with this. Oh, this one is not that loose. Yeah, but these are more loose. So when these can, the springy contacts here, when they can move around like that, then it means that we can have some dirty particles under this, and that means you'll have a bad contact. But it's a Kelvin system, so that means it's a 4-point resistor measurement where you have current going through these two wires, and then you're measuring voltage over your resistor. So that means it shouldn't really matter that much how good a connection there is, really. Of course, if you have too much voltage drop, so you can't supply the current or don't have enough good connection to measure the voltage, of course you're gonna have a problem. I have a long history with playing around with 4-wire resistance on my other instruments, so I know it is actually a problem. Ooh, loose. All this is feeling. It's it's the whole that connector. Yeah, those are good and stable. Is it there? Let's try again. Oh no, there's an issue here. This connector is loose. So I think we're going to have a problem measuring. And that one is good and tight. Okay, I'll go and play a little bit with this. I must say the first impression here is quite impressive. So this is a 1 ohm, 1% metal film resistor, and I get quite a lot of digits out of this. So if this is ohm, that will be milliohms, right? So it's 5.8 milliohms over 1 ohm. Okay, so if I move to the end, I get almost 1 milliohm extra, and that is about normal. See, for this length of pin, they feel very loose, I must say. I also tried to poke around that little loose connector, and it seems not to affect the result. So that is very, very good. It's only a mechanical thing, how it looks and feel, but it's not really doing anything electrically loose connections or anything. All that is perfectly fine. Oops. The instrument is very, very fast. I don't know how visible that is. You can see here. It's doing, I think it's doing 30 measurements per second. So it is very, very, very live. I'm very impressed by that, by the way. See, it's set for 1 ohm go, and then you get a little go here. I don't know how visible that is. That will be the indications that goes out in the handler. Those indicators, we got 3 here and 3 here, and they go straight out the back connector and can be used to lock whatever it is you're doing. So all that is just amazing. I think I'll try with, let's try and take exactly this resistor and let's call it 1 ohm and 6 milliohms. Okay, now let's try and test it with something else I got. So this is the same resistor. I really tried not to touch it, and I tried to measure more or less the same location on the resistor. So yes, it is 1 ohm and 6 milliohm, and a tiny little bit. Those grippers here, they're really a lot more tough. Let's go to the very end and then see, goes to almost 8 extra. Okay. And the funny thing is, I can also do this on my key side, and it's like again the same resistor, and now it's a little bit higher value. Maybe it's because I'm gripping a little bit further apart. It's all about where you measure on the length of the lead. When it comes to these tiny little milliohms, I'm at the moment running a very long smooth filter, and that is why it takes quite a long time until we get the super good result. We can remove the smooth filter and then it's gonna go faster, I guess, right? So that was 7, and if we go all the way out at the ends, and of course I should not touch those wires as well, by the way, because everything will affect measurements when we're dealing with super small values like this. Why is it taking that long? Here we go. So that was 8.2 milliohms extra. Yeah, so that's a little bit interesting. We have a tiny little bit of a difference in the very small milliohms. Oh, that was funny. I just moved the test leads from the key side to this instrument, and that does give me a lot better grip and a lot more stable readout, I must say. And the readout value is very close to the same, depending on the distances here, right? Look how fast it is. I mean, absolutely impressive. Here is really a funny thing. I am now in the milliohm range. This is the lowest range. You can select between auto range or manual range. I found it actually easier just to short it and then go out of auto and into manual, then it goes into the correct range. So I don't know if it's easier to dial up and down in the ranges, but I thought that was a smart way to do it. I told you it uses 8 watts of power consumption, and of course now when I short the leads here in milliohm range, the power consumption goes from 8 watt to 14, almost 15 watts on the mains line, and that is of course because it's pulling 1 amp through the test, and that's generating the voltage it's measuring and calculated into resistance here. So this is 0.5 milliohms and then 2 more digits on milliohms. So let's try and see 0.8 when it's this distance. I mean, it's absolutely amazing. And that fast it is, and that stable. I can really go that close. Oh, it really works. Super fantastic. I am very impressed. I can't help it. I'm still yelling and screaming and step dancing around here, I must say. Oh, this is 1.002 milliohms. And yes, I believe this resistor here is 1 milliohm because this is 60 amp, 60 millivolt power shunt, and it's one of those that's trimmed to a very high accuracy. And what do you know? Look at that. Is 1 milliohm. It all depends on how well I'm... No, it shouldn't affect so much because this part here is just solid brass. So it doesn't matter really where I measure this, but it is in this point they put the calibration for this unit. That is how crazy it is. Super accurate. Yeah, let's try and open up. Wow, man, it's 2.7 kilos, by the way, so it really feels like it's super heavy. Yeah, I think it's just this screw. Is it really that simple? I don't see any screws here on the bottom, so it's probably that simple. So I wanted to show you how to open these things, because the most obvious is you take out this screw and then you pull back the top, and that is also how it is done because it locks around the sides and all that kind of stuff. And there is a push release here at the front where you push here and then it releases, but of course none of that works before you have released these, and you need to take out the handle, of course, and that is done by rotating it, as you can see here, at the correct angle, and then carefully pulling it out. And then we should be able to, oops, release these. Let's look a little bit inside this fantastic unit. There's a very, very big transformer. Oh, why is it that big? We even get all the different voltages, all the different windings is completely explained here in the text label. That is just fantastic in case you need to service any of this. So I totally like that. That is of course the high current driver for the current source. We got a relay to enable and disable that, and that is the test interface, completely optical isolated, and that is the temperature sensor wires. And there's a little, I think it's a PT100 driver down there. So you can put a temperature sensor here, and then it can do temperature compensation and stuff like that. I see a little bit of nice, sexy components. See, this is the LT1097, so this is a pico amp, ultra accurate op amp. Oh yeah, and that one down here is the LTC1052. That is a zero drift chopper stabilized op amp as well. Super high precision, goody stuff. And all the relays for the different ranges, and of course big hefty current sense resistor. Oh, look at that. And all the other ranges just uses smaller resistors, of course. And so that will be the brain section, and that will be the CPU. Novoton W78 CA032 something. I don't know that microcontroller. We got some RAM. So that will be the RAM. That is the EEPROM. That is of course the software. And that will be all the LED displays and the switches. That's probably some common anode or common cathode drivers for the way that the multiplexing works. All the multiplexing is done by the ULN 2003. Classic drivers for that. Port expanders, and yeah, just the regular little microcontroller section here. Power supply for the little microcontroller stuff, and optical interface to all the measurement stuff. I mean, it's really made top professional, but it's also a 30,000 count ohm meter, really. So of course it needs to be made to the top nicest stuff, everything here, right? Oh yeah, top precision. Everything is just yeah, honestly super nice. Of course the on-off switch is also mechanical down here, so there's a, that is super good because we don't want mains voltages all the way down here, and rectifiers and all that ripple current stuff far away from all the nice and sensitive analog stuff. So all in all, they did very good thinking. Yeah, I even see a mains input filter there as well, and another rectifier and capacitors and good stuff here. And again, you can see it's pulled away as much as they really could for good signal to noise ratios and all that kind of stuff. Yeah, absolutely nice. The only really bad thing I can say about this unit is it smells like ashtray. Oh my god, there is going to be a lot of clean with alcohol, but the problem is the relays, they're not always completely closed, so you can't just take out everything and put it in a bath of alcohol, because it's probably going to go inside some of these relays if they're not specially made for washing. So I think it's going to be a manual cleaning process. I mean, even if I have it as far away as I can, I really stretch my arms here just to be able to breathe, because it definitely smells like ashtray like when it is open. When it was closed, I think it has been washed on the outside. It's not super nasty or anything on the outside. It doesn't really look a lot of nasty. You can't really see the smoke stuff, but it definitely smells like somebody left an ashtray in here somewhere. But yeah, that is just how it is. Let's try and play a little bit with the high and low and the different resistor checkers. So here I got a little pack of different resistors. So I'm taking the 1 ohm resistor is my reference at the moment, right? This can of course be reprogrammed. So if this is 1 ohm, right? And here is the normal, is 1 ohm is my reference. And then I have a high and a low 10% accept factor, then it is go. So if I put back my 1 ohm resistor, let's take a 1.1 ohm. So that should be 10%, right? Of course this is, how funny is that if I grab it all the way to the end? No, I can't make it fail. Let's take another one. If I'm lucky, the other one will be. No way. How is that possible? Why isn't this failing? No, this is a 1 ohm resistor. Okay, crap. Let's take a 1 ohm 2, right? That should be 20% off, right? Haha! Look at that! It works. Okay, this is a 1 ohm 3 that I found, right? So 1.3 ohms is high because it is more than 10% off. How nice. This is a 1 ohm 2, yeah, and that is still off. And then if I take a 1.1, it is okay. No, there was exactly one here. There was a little bit high on the 1.1. Look, it says high here. And if I grab it all the way in here, it is still too high. Yeah. Anyway, I didn't want to bore you with a lot of testing and all that stuff. I just want to say how it can do all these things, and it's absolutely fantastic. I really like the instrument. It is so fast. It's just incredible. Anyway, thank you for watching and have a good day. I hope to see you again very soon. Bye bye.